All right, moving on now. So I mentioned that there are going to be some problems with this as I'm using polylines. That's a very important thing. When I go to curve and under spline, there's this tool right here that's called polyline. All it does is just create a line form of the connection between the points that we just generated. So if you did it wrong, then you're going to see that problem once you do this. So you take your bottom points and you connect it with a polyline. It'll look something like that. Then you can do the same thing with your top points, and it's going to look something like that. So now, kind of jumping ahead a little bit, I want to kind of bring us forward to what we're actually going to do. So this is the construct for the exterior wall, as well as the construct for the interior surfaces. So when I am creating the exterior wall, I'm essentially creating a ruled surface between the top side walls and the bottom side walls. So I could do that using ruled surface, and it's going to take my two polylines and try to loft them together. So I do the A input and the B input like this, and this is what I get. Why do you think it looks like this?
Because,
Critical thinking caps, everyone. Why does it look like this?
The order.
Hmm?
The order?
Not necessarily the order. It might be for some of you the order, but for me, I have a problem because I have 5 points on the bottom instead of 4. So here's what I've got to do. My exterior walls, if you notice from what I just showed you, I'm thinking to myself during massing that I'm only going to mass a wall on 3 sides. And the front is going to be all curtain wall. So I don't need to loft the front face, and I don't need that connection from this point to there to be lofted back. So I'm going to basically redo my bottom points, and I'm going to just select the back 4 points and hit enter. And oh, look at that. It gave me a reversal. All right, let's reverse it. That's funny. Those are my bottom points. Top points, set multiple points. 1, 2, 3, 4. Enter. Oh, there we go. Okay. So I guess what happened was when I manually selected left to right, it was different than when I automatically selected it. Must have gone from right to left or vice versa, if that makes any sense.
I didn't do it.
It might not. What it should look like is this.
Which command you use to
You
reset
only have 4 points
the
on
point?
top, right?
I'm sorry?
Sorry, you only have 4 points on top?
4 points on top. I created 5 on the bottom, but I'm not including the 5th. And to answer your question about what I used, all I did was set multiple points. And I just selected the 4 of them over again.
Okay.
So if yours is twisted, try taking one of your lines and selecting them in the opposite order. Anyway, I want to point out one thing here, and that's this kind of a thing. So for some reason, when you're working with polylines, polysurfaces, and stuff like that, in these really compound Grasshopper forms, you'll notice that some corners get cut off. There's a test that you can do to make sure these corners are actually calculating properly, and you should get used to actually doing it. And it's really just to bake. So all you have to do is select the object, bake it, and look at what that corner actually looks like when it's baked. So even though my Grasshopper volume is showing me a sort of rounded corner or a chamfered corner there, it's actually calculating the full corner. Okay, that's good. That's what I want. I just want to point that out. So let me just pause real quick and let you guys get caught up with that and figure out the point order, and then we're going to move on to actually mapping some things. Before we move on, guys, just delete the geometry if you did a check bake, and then let's move on from there. So here's what we're doing, right? We basically have our exterior wall, we're going to have to create a front face. We're going to create a top and a bottom to just get us a volume. We may or may not need the volume, but what it gives us a lot of latitude to do is basically re-deconstruct it later in order to isolate surfaces. It just creates a contiguous surface, and it gives us more flexibility. So I am going to create the bottom surface using basically a connection point of the two ends of that polyline. And then I'm going to create a 3-point curve using the middle point. And then for the top one, I'm going to just create a rail across it. And so what I'm going to need is, under the curve analysis tools, I need to find the endpoints of both the top and the bottom polylines. So on the bottom points here, actually what I want to do with you is flip my top and bottom, just so it reads a little bit more logically. So on the bottom, I'm going to find both of those endpoints. And at the top, I'll do the same. But the easy part is to create the rail at the top. All I have to do is go to curve and primitive and add in a line. Creates a line from 2 points. Now on the bottom one, I will be using a curve 3-point in order to create an arcing curve, right? So that's also under curve and primitive. And make sure you're selecting arc 3-point. Sorry, not curve 3-point. You could also do it technically with a spline or something like that, but an arc is going to be absolutely round, so, and not parabolic. So with the arc, it's going to ask for your start point, your middle point, and then your end point. So that means our point that we currently are not selecting over here, this one in the middle, is going to be the middle point, or the point arc interior. So I need to first reference that in. So I'm going to drop in another point param, and I'll set one point to that. And then my curve start point will be A, and then the point I just referenced will be B, and then my polyline endpoint will be C. And as you'll see, that creates an arc across this. And then finally, the last part really is to just loft the two of them together or use a ruled surface. I want to point out, though, that this is an instance where lofting and ruled surfaces are going to create a problem. So I want to just warn you that I want to walk you through developing it this way and then going back and showing you how to just fix a problem like this in the future. I think that's more valuable. So I'm going to do that, just giving you a warning. So we're going to do a ruled surface for this as well, and that's going to go under surface and ruled surface here, and I'm going to take this line and connect it with this arc, and that creates my front surface like this. So we've got two ruled surfaces all ready to go. Any questions so far? Okay, so I want to close this thought by showing you how to create a solid out of it. And it's actually remarkably simple, but it takes two steps. The first thing we have to do, well, I should put it this way. Right now, we basically have some kind of an extrusion or a loft between these two things, and it doesn't have a top or a bottom. So for those of you who know Rhino, what's the command that you would use for an extrusion that doesn't have a top or a bottom? Well, I mean, you could do it during the lofting process, and the setting is called cap. Or if you've already done the loft and you want to close it, you can type in the command cap. So that command exists in exactly the same form in Grasshopper. It's just called cap ends, or cap holes, actually.
Cap holes.
Yeah. But what it's going to request is one brep. And that brep needs to be a closed brep. So in order to close these two surfaces, what do I have to do? Any ideas? Just a guess? Something you do in Rhino all the time? Join. Thank you. So under, I believe it's actually under intersect. I could be wrong. Let me check where it is. brep join is under surface utility. Sorry. So this is a new one. I'll label it for you. All you're going to have to do for this is just drag your first ruled surface in and then your second ruled surface in holding shift. And you can turn your old stuff off and you'll see that it creates one solid geometry.
You turn everything else off?
Yeah, I did. And then you just take your brep output, which it should have one open brep listed, and just plug it into cap and it creates the closed volume. So do I absolutely need to join it and cap it? In many cases, probably not. But what this gives me flexibility to do is run a deconstruct brep, and now I can just get all of the individual sides, all of the individual edges, and vertices as a singular list, should I need it. So it's just an extra 2 or 3 nodes that you have to drop on there in order to get it done. It's a best practice for me. I like to have it. Okay, any questions so far? All right, so let me stop this, make sure you're all caught up, and then we'll move on with the actual deconstruction part.